Hi friends, I'm really excited to see you again. In the last two videos, we talked about the history of AI and also about the importance of data in AI. So I think it's really the time to understand how machines are learning from data. So for that, let's dive deeper to understand how it happens.
If we represent AI with a fun diagram, so AI would be considered as a broader umbrella that could encompass concepts like machine learning, deep learning, Gen AI, foundational model under it. So let's just define what exactly machine learning is. So machine learning is nothing but a subset of AI that uses computer algorithm to analyze data and make intelligent decisions based on what it has learned from the data instead of just following a rule-based algorithms. So now I'm going to give you an example that is we have a data that's the history of patient with a heart problem, and then we'll be trying to solve that problem with the two different approaches. First with the traditional programming approach, and then we'll be also trying to solve that with the machine learning approach. So for that, let me just give you the data set first. So for now, do not really pay attention to the different features in the data, but now let's just focus on how these two different approaches will solve that problem. So let's say we have a data set, that's what we call it in machine learning and data science world. So this data set is having 4 different features and then a target variable, what we call here as y. And then the target variable actually says whether the person heart failed or not. So let's say the features are age, sex, and BMI, something like call it body mass and like body mass index, which is nothing but a derivation of a person weight by his height, his or her height. And then we have a something called BPM or beat per minute. So then we have some toy data here. We're just entering some toy data here, data points that say 45, 60, and 30, 80, 50. And then for the 6, we have the 1 and 0, that 1 represent a male patient and 0 represent a female patient. So we have 1, 0, 1, and then 0, 1 for the BMI. We have 25, we have 30, we have 22, we have 28, and then we have 35 also for the BMP. We have 120, 140, and 100, 160, and 130. The result is 1 or 0 again. This is also a binary variable that 1 stands for heart failed and 0 for heart not failed. So again, notice that this is just the toy data. So here, every column here is considered as a feature, and every row is nothing but a data point. That's what we call it in machine learning and data science world. So let's say we have this data and we're trying to state a problem that to what extent is it possible that a person data or the person health features data would give us a sort of understanding whether that person's heart may fail in the future or not. So first we want to try to provide a solution with the help of a traditional approach or traditional programming approach. So in the traditional programming approach, how we would solve this problem is we have the data and then we are trying to define some sort of rules, which are basically nothing but if and else rules. So the result will be an algorithm that we have designed with the help of if and else. and then we are going to get the answer when a new data point is coming. So let's say a new data point with a certain values for every feature is coming to the system. You just give this input to the system, and system will make a predictions for you whether this person heart may fail or not. But the drawback with this system is you need to identify, or you need to modify many factors here when the data, for example, change, or if there is something happening. So a new input is coming or a new feature is added to this data. You need to change a lot. You need to change the entire code here. Whereas in contrast, if we try to solve this problem with the help of a machine learning approach, we would be having the data, and then we also have the answers, which are nothing but the target variable, or y here. These are nothing but the answer that we have already. And then what we are going to do is we are going to pass this data to a model, a statistical model, a machine learning model. Those are already developed by many pioneers in the field, and they are already available on different libraries like Tiano, like PyTorch, for example, TensorFlow from Google, Keras from Google, sklearn, and many other libraries. So what are you going to do is you call a feed method, which is more of like programming terminologies, but still, I'm just trying to make things simple. So what you do is you pass the set of features or X that you have along with the answer that you have, and you call a feed method on that specific model. Notice that you always decide to choose the right model based on your data. So it's not that you say one model is defined here and it's going to solve all the problems. No, that's not true. So you look at your data, you look at the features, you look at the type of data that you have, and then based on that, you will choose one specific model that could work for you, that could give you the best answer. Again, so once you call the feed method on that specific model, what will be the result? The result will be a fitted model. So this is a fitted model or a trained model. We call it also a trained model. And this model actually has its internal features like coefficient, the weights, and the threshold based on the data that you have provided to this model. So this will be a trained model that in the future that you can take it to the predictions. Well, of course, this is an example, but I'm just going to give you an idea. So you can take this model to the predictions, to the production environment, and then you sort of pass an input data to that, and this model will make some sort of prediction for you. So the good thing about this approach is when something changes in the data, for example, new feature is added to the data, you're not supposed to change everything in this model here. What you're doing is you're just trying to retrain your model, and then a new pattern of your data will be captured by this model without changing anything in the model itself, in contrast to what we are doing in the traditional way of programming. So if I try to give you a basic idea here, is if I'm trying to explain this in a Cartesian plane, so it's just one feature. For example, it's the H feature. I'm not able to represent this with all the features that we have in this data. Well, in the real world, there are like hundreds of thousands of features, which is really hard to visualize. But in this example, I'm just trying to sort of giving you an idea with just one feature, H, considered here. And Y is the target variable, whether the heart failed or not. So you have your data points here. And what the fitted model is actually a line that has fitted throughout your data. And if a new data point is coming, it's trying to find its respective value on Y for you. And that's nothing but whether the heart fail or not. So every data point scheme coming here is somehow compared to the fitted model, which is nothing but the trained model, and it will give you a sort of predicted output here. So when we go to real implementation, we have a the predicted value and the actual value, and then we have to try to minimize this value between them with the help of the loss function. And then we have the optimization function. That's a totally different topics that we'll be talking about. That these are more complicated topics that we'll be covering in the next video. So in the next video, of course. So I hope I've given you some sort of ideas here. But now the point here, the main points here, is that we have to learn the different methods of machine learning, or the different methods that a machine learns from the data. So the first category will be supervised learning, meaning that machine learn in a supervised way. So the word supervised come from the data. It means that in this sort of learning, we have the set of feature X, and we also have the target variable Y, that machine will learn how to map X to the respective Y. So in this case, if you have a lot of label data, so we should have label data in this case. So in this case, if you have a lot of label data, then proportionally, your model will be able to make a good prediction as well. That's why this is heavy, this is costly. And this is one of the approaches that, like one of the famous approach being used nowadays, but it's costly because of the data, because of the hardware that you need to train, and specifically because of the data, because you need to have quality data in order to get a model that would make a best prediction. And then you have another category is called unsupervised. So in this unsupervised method or unsupervised learning, is machine is learning in an unsupervised way. It means you have data that they have the set of X, but they do not have the target variable Y. So we're not having the target variable Y. We only have the set of X or features. So what the machine learning model here is doing is trying to cluster your data into different clusters. For example, for our data that I provided, let me say we're not providing the set of Y to the model, and we ask this model to cluster our data into two categories of, let's say, high-risk patient and low-risk patient. So one of the common algorithms that we use here is called k-means. So with the help of k-means clustering algorithms, what we're going to do is we're going to cluster our data into two categories of high-risk patient and low-risk patient. Or another example would be that you take the network traffic and pass it to an unsupervised model. The model will be able to give you the different clusters for your client. For example, if you are a network provider or a cell phone network provider, so it will cluster your customers that on which geographical location they are online, and where you have the highest network traffic from which geographical area, and so on and so forth. So in the third category of machine learning is called something reinforcement. So we call it reinforcement learning. In short, we call it RL. So in this approach, what happens is you define the set of rules. You also define the set of constraints. And what happens here is you make an AI agent that would be able to achieve the goal within the certain constraint that you have defined. And if the agent is able to achieve the goal in a way, then you will have a function called a reward function that would reward the model. And if the agent is not able to achieve the desired goal, then you have a function called a penalty function. That you will sort of penalize this agent. So reinforcement learning have its application in areas like self-driving cars, in areas like robotics, for example. It's considered that you make a robot that would do the household work. So you see that every house is designed differently, and there's a lot of constraint in the house. So you want this robot to navigate safely in the environment of a house. So you're trying to design an algorithm that would let this robot to move carefully, not to hit around in the house, not to hit his head, break this one or that one. So you are trying to teach this robot in a way that he has to be able to navigate safely. If it is able to achieve its goal, then you reward it. If it's not able to achieve its goal, then you sort of penalize the algorithm until it's able to achieve the desired goal within these defined constraints. So I hope you got sort of a general idea on how machine learning is different than a traditional way of programming approach to solve a problem. And of course, stay tuned. I'll be coming with more like useful videos. And if you have any question, you can post in the comment. Or if you have any suggestion, it's always welcome. You can just post in the comment. So I'll be seeing you in the next video. And till then, take care and have a nice time. Bye.